Hello, everyone. Come on in. Sorry about the difficulties Friday, Saturday, and Sunday. Seems like everything came up today around somewhere between 11:30 and 1:30. I don't know what time actually. Uh, we've got some issues pertaining to that anyway, so we're still going to have some issues regarding the Canvas class. I'm not exactly sure how it's going to play out because the people that handle Canvas and SIS don't have anything to do with Pearson, and the people at Pearson don't have anything to do with Canvas and SIS. So I've got to figure out what's going to go on with that. Is everybody able to hear me? Okay, thanks, Lauren. I had one look that looked like I don't know what he's saying. All right, so you should now have in your Canvas dashboard, you should have a PHY 241 D02B, which is our original course. You also have a PHY 241 N01B. They told me that's the one that we have to actually go to. She told me that she's copied all of you into that, as well as all your grades and all the assignments. So that all should be fine. The downside is I'm not sure the actual homework system is going to work now that they've made an entirely different course. So when I get off the internet tonight for this class, I'm going to be contacting Pearson and try to get that finagled. So the downside is you guys still need to be able to do your homework. What I would recommend, at least regarding the chapters that we've done, is try to do the odd problems. If you can't get to the homework, try to do the odd problems. And if you turn those in, I'll substitute, I don't say all the odd problems, but I'd say at least maybe the last 50% of each section, or maybe at least the mid 50%. Because I don't want them all to be level ones. I want them all to be like some ones and some twos. So within each section in the chapter, not necessarily the general problems, but the subsections, that should be sufficient. And if you do that, I'll give you the same number of points for the assignments that I assigned. Actually, I'll probably give you more, but that's just for the missed assignments. So if you run into a case where you can't get to any assignments to do a particular assignment, then just do that so you can practice. The practice tests, of course, will work. So those are always good. But in lieu of the homework assignment, that's something you can do if you just can't get to it. But I hope we're not going to have any problems. I'm praying that maybe it just automatically works already because they copied everything in. I don't think that's the case, but God, I hope so. Okay. Does anybody have any questions on anything? We need to resubmit the extra credit if we did it. You shouldn't need to. I will check. I'm going through the course right now. I will check and see if that's something that I've lost. I can do that in real time right now. So I just have to pull it over to here. Ooh. Of course I did that. What row? Well, that's not cool at all. Okay, this is weird. Let me see what's going on now. Oh my goodness, oh my goodness. So yes, it's already started happening. Let me check on the other side. So I just pulled up your grade book and I looked and all your names were there and I was waiting for the assignments to load up and then all your names disappeared. So I'm now checking in the grade book on the new course and hopefully they're all in there. If not, I'm going to have a minor heart attack, just a minor one. Maybe a stroke too. Let's see. So all your names are there. That's real peachy. I don't see a single darn assignment in there. That's not cool. Okay. I don't even see the test you took in there. Son of a. Okay, so this is a suboptimal outcome. So we're gonna speak with the people. I'm gonna speak with the people at Canvas. Hopefully they can rustle that up. I'm not confident of that, but hopefully they can. I will let you know. Yeah, there are literally no grades right now. I will let you know as soon as I can. Right now, we're just going to go on the assumption we've lost everything. The good news is all our mastering stuff is still on an entirely different website, so that stuff will be fine. However, we did lose your test. We did lose your extra credit assignments. If you still have those files, of course, you can resubmit, so that should be fine. And hopefully you do. But like I said, the tests we might have to renegotiate. That's so I will make sure the practice tests are back up as soon as possible if they're not already. And I apologize about all this happening. It's somewhat my fault because I did tell them that the course was labeled D02B, but since it meets after 5 p.m., it's supposed to be considered a night class. So I told them they needed to do that. They told me they needed to wait until enrollment settled down before they created that, which actually was the real problem, because if they'd done it before classes started, it wouldn't have been a big deal. But now, since they did it after classes started, all this has happened. It basically erased the other course and then created the new one. Yeah, someone asked that. That's cool. So anyways, I will. I'm sorry, I'm getting some messages on the screen right now. I'm trying to make sense of them. Okay, so I will get on top of that, try to figure that out. We have another test coming up for chapters 3 and 4. We already had a test for chapters 1 and 2. The grades were pretty good. However, we did have some people skip them. So I'm probably going to reopen that. Y'all have seen the test. Those of you who took it, and those of you who haven't, you get another chance. I'll give you 3 attempts still and all that stuff. I'll probably make them available over the next period of time, and I'm going to have to give you some extra credit just for the problem. So I apologize for that. I'd like to just give you all 100, but I think you'd be aided more by doing it again. That would be more in lines with prepping for your midterm and all that good stuff. And like I said, I'll give you some extra credit points on that anyways. No matter what, I'm probably going to add, let's say, 5 points to each person's to the test 1 grade. So no matter what, whatever you get on this time, I'm going to add 5 points to it. If you tell me that you got higher the last time, I will try to verify that and add 5 points to that. Okay. So I'm sorry, guys. You should not have to redo any homework because that's all on an entirely different website. The only things that are missing are practice tests and tests and extra credits, but extra credits, since you submitted them as a doc, you should probably have that document somewhere. So that shouldn't be too bad, hopefully. I'm sorry, everyone.
Professor?
Yes.
The Zoom meetings are also not in Canvas.
Yeah, that's why I had to put it in this one.
Yeah, and I also didn't get the email at the beginning of the semester with all the Zoom links listed. So
well, yeah, that's no problem. I got to remake that in the other class, so I'll make that, and it'll go out to everybody automatically, and then you'll have the new link, and it's going to be in the N01. This class is actually going to disappear. The other class should reappear, and hopefully the lady copied everything. She told me she'd give me access to it for the rest of the semester, in case I find something missing, but I didn't know all the grades would be gone, so that's kind of a bummer. So anyways, my battle plan for today was to solve some problems for you guys along the lines of chapter 3, which is the projectile motion problems. So what I'm going to attempt to do, if it'll let me in there, I'm going to use the old course. I'm going to go to my lab and mastering, and I'm going to open up the textbook and then hopefully use that to pick some problems at the end of the chapter for you guys, and then I'll just solve them just to give you some extra help and extra experience with seeing at least physics problems solved. So I'm opening the book now and I'm getting ready to share the screen with you. Let me go ahead and do that. I'll share screen. I'm going to do, yes, I guess it would be this screen would be the best one. And yes, you guys are seeing the book. Now I got, of course, this is for my 242 class, which obviously y'all don't want to know anything about capacitors at this point. But I'm going to go down here to the problems section of chapter 3. And I'm going to pull up some problems to do. Now I was looking earlier at these for some problems that might be kind of difficult. I ended up choosing to do I think I ended up doing number 8 with a misprint. I realize now that I was using it as if it was 835 kilometers per hour when it was in fact 815 kilometers per hour, but I did it consistently right. But at the same time, I also thought that was a lot more difficult problem than it was. So it was kind of a wasted one to do. I want to give y'all a little more robust problem to do. Let's say we do 3 vectors are shown in figure 341. Their magnitude are given in arbitrary units. Determine the sum of 3. Okay, I think that's a good one. I'll do number 10 for you guys. So I'm going to write down the data for number 10 on the little sheet within my good notes. And then I will share my good notes with you. So what I have is, and notice they're just using arbitrary units here. So I'm not putting units. That's really bad practice. I don't know why they ever write a physics problem this way, but they did. So I'm going to write number 10. And I've got A equals 42, which is always a good number, at 28.0 degrees. 42 because of Hitchhiker's Guide to the Galaxy. I think y'all would like that. B is 29.7. Again, no units on these, so don't get into practice of this. And I'm going to say this one is at, well, I will say 56.0. And I'm going to call that north of west. Okay, you can see how it is there. We're generally going to treat y as the north, x as the east, negative y as the south, negative x as the west. So I think you can probably understand how I would call that 56.0 degrees north of west. And then C is going to be 31.0, and that one's going to be due south, which I'll call 180 degrees at negative 180 degrees. Because negative 90, that's better. And I'll say that's 3 sig figs as well. So the reason why it's negative is if you measure clockwise from the positive x-axis, that's an automatic negative number in the general math description. If you measure counterclockwise from the positive x-axis, whoa, that's crazy. I somehow just wrote on my book. Don't know how I did it. Anyways, if you measure counterclockwise from the positive x-axis, that's just the regular degree or angle with no negative in the math world. So that's really what I'm sticking to. What they're wanting to know is give the resultant in terms of A, components, and B, magnitude and angle with the positive x-axis. So that's really the question. So I'm going to stop share now. Hopefully it's going to share the screen with my iPad. And I'm going to attempt to do that now. You know, there's always a fun little problem with that. So I'm going to open this up. And it looks like it worked. Yay. Okay, so what I have here is these vectors, and we could take time to actually write them on the axis system, and that actually might make it look a little better. So for instance, this first one was only at 28 degrees and had a magnitude of 42. Okay. The second one was at 29, or excuse me, was at 56.0 degrees north of west, and that had a magnitude of 29.7. So I'm going to say like this. And then the last one was straight down, and that had a magnitude of 31, which is like that. Okay. Now I'm going to put this angle as 28.0. I'm going to put this angle as 56.0. And what that allows me to do is now make sense of what the coordinates are. So what I'll do is I'll use green for positive and I'll use blue for negative, say. So I can see that the vector A is there to the right. So that has a positive x-axis, because if I try to walk from the tail to the head and I first go along the x-axis, I think you can see that I have to go to the right. And then if I walk from the end of that to the head of the vector, I have to walk up, both of which are positive directions. So I'm going to just go ahead and arbitrarily write the trig functions. This is what I recommend my students to do, at least initially. So I'm going to write sine of 28.0 degrees is equal to, and then we use either some old horse or SOH. So sine equals opposite over hypotenuse. And the opposite, of course, is AY. And the hypotenuse is, of course, 42.0. Again, no units, but that's intentional by your author. Cosine, again, just arbitrarily writing the angles. Okay, just so we get used to it. That's ka, or K my horse, which means cosine equals adjacent over hypotenuse. Adjacent is the side that's touching the angle, but is not the hypotenuse. Remember, the 90-degree angle has that little box on it showing us a 90-degree angle. That little box looks like an arrowhead pointing to the hypotenuse. So in this case, I'm going to get A sub x over 42.0. Okay. But I see they're both positive. So that's the first thing I'm going to work with, is I'm going to compute them and force them to be positive. So A sub x is equal to positive. So I just force that positive to be there. 42.0 times cosine, 28.0 degrees. And 42 times trig function cosine 28 gives me 37.08 units. Okay, so I'm just saying the word units, but I'm just leaving it blank again. This is not good practice. I don't like doing it, but that's all we can do at this point. AY also is positive, so I'm going to force right here for it to be positive, just like I did there. It's going to be 42.0 units times the sine of 28.0. Now, it's not always the case that the sine gives you y and the cosine gives you x. If I would have chosen, for instance, instead of the 28 degrees, if I would have chosen, say, the 62 degrees, from the positive y-axis down to the vector, then I would have got exactly the opposite function. So anyways, in this case, I got 42 times sine of 28. This gives me 19.72 positive. Again, that's just plain units. Now I can look at the vector B. which is right here. And of course, its magnitude is 29.7. But we notice that the x component of this one is in fact negative. And the y component is in fact positive. Okay. Again, I'm just going to arbitrarily take my trig functions and write them out and then use it. So I'm going to say the sine of 56.0 degrees, some old horse, is equal to by over 29.7 units. And cosine ka, or came a horse, 56.0 degrees is equal to adjacent over hypotenuse, which is bx over 29.7. So I'm going to say bx, which is actually negative. So I'll force myself by writing that little negative sign there, is going to be 29.7 times the sine of 56.0 degrees. So I got 29.7 times the sine of 56.0.
Wouldn't it be cosine?
Oh, thank you. Yeah, I wrote it backwards. Thank you for catching that. That's very good. Let me kill this right quick. I'm going to erase this. I was just finished telling y'all that they're not always sine and cosine in the way that we said. But in fact, by should be sine is opposite over hypotenuse. So sine is definitely given by, and cosine is definitely given bx. Thank you. So yes, bx is equal to negative 29.7 units cosine 56.0. Thank you for catching that. That was very helpful. And I'm going to say 29.7 trig function cosine 56. So that's 16.61. So that's negative 16.61 units. And then by, that's actually a positive. So I'm going to put a positive 29.7 times the sine of 56.0 degrees. Again, forcing that to be positive. That one turns out to be 24.62. Notice how I've kept one extra sig fig on all these answers. That's always good practice. In the intermediate steps, always add at least one extra sig fig and make sure you mark it so you can tell later that it's not supposed to be counted. And then when you add everything up, do all the work, you can round it to the appropriate place and you won't have like triple and quadruple and quintuple rounding. Now, finally, the vector C is the easiest of them all because the vector C is only acting along the negative y direction. So its only vector component is in fact a y component and it's negative. So I'm going to say C sub y is equal to negative 31.0 units. So the resultant, which is the sum of all those, we often call it resultant. So I'll call it R. So R sub X is equal to the sum of the X components. So I've got a 37.08 units. I've got a plus negative 16.61 units. And I got a plus 0. And that gives me a 20.47 units again. Notice my sig fig is still one extra. My RY is equal to 19.72 units plus 24.62 units plus negative 31.0 units. I'm being really pedantic, making sure that y'all see I am technically adding everything, but some things have negative signs. So 19.72 plus 24.62 and then plus negative 31.0. That gives me 13.34. Again, one extra digit, so 13.34 units. So I can say R, the resultant vector in component form, is 20.5 units I hat plus 13.3 units J hat. Now we can also draw another coordinate system so we can faithfully represent this vector. Okay, there's my X and Y axes. I can see that my X component is going to be quite a bit bigger than my Y component. So I am going to take that and write it right here. Whoa, that was bad. And then I'm going to take my Y component and add it right to the end of that. Okay, this one, the Y component happens to be 13.3. Ooh, I'm still not thinking. That looks close enough to 13.34. And the other one was 20.5. So R has a magnitude equal to the sum of the squares, taking the square root of it. So now I'm going to call this angle theta. So R would equal the square root 20.5 units squared plus 13.34 units squared. And now I'll take the square root of that. That's the square root of 598.2. And that gives me 24.46. Units again. And of course, theta equals tangent inverse. And I was telling the class today, we usually use tangent inverse because the calculation of adding vectors normally spits out your X and Y components. If we wanted to use sine or cosine, we'd have to use the R. Well, the R not only has the X's and Y components that we calculated, but then it had another calculation on top of that. So I've got basically 1 1/3 times more chance of having an error in that than I do in having the X and Y. So it's best to use ones that are closest to having no calculations whatsoever. So I'm going to take the inverse tangent of 13.34 over 20.5, which obviously should be well under 45 degrees. So, and that's sort of a hypothesis you should do just to make sure it makes some sense. So 13.34 divided by 20.5. And that gives me 33.05. degrees. So I could also say R is equal to 24.5. Notice that's measured up, that theta is measured up from the positive x-axis, so I can just call that at 33.1 degrees. Now, I should have actually specified that this was 5.3. That way you would have known that it wasn't a 4 with a 7 next to it that I rounded up to 5. So whenever that last digit you're going to include on the extra sig figs, whenever that's a 5, you should probably carry the next one too, just to be safe, so you don't mislead anyone. So any questions on that problem? That's pretty straightforward, right? Not too hard. I was actually looking for even a harder one than that, but that's sufficient for. I think I do a plenty hard one on the on my YouTube channel where I did the world's greatest vector addition problem. I'm going to stop sharing this now, and I'm going to go back to sharing the book, and let's find another problem to work. Okay, so that was number 10. Now, see the rest of these, well, at least 11's not, but once you start getting into number 13 and all that, everything's in terms of I, J, and K, and that's like the easiest possible way to add vectors. So I don't find much use in showing you those examples. Let me see, what is 17 saying? Two vectors, V1 and V2, add to a resultant VR equals V1 plus V2. Describe V1 and V2 if VR is equal to V1. But that's a good question. I think I will do that. So let's look at number 17 now. So I'm going to go ahead and write down the details. The details are that number 17 is the one we're solving. We say VR is equal to V1 plus V2. And what they want us to do is describe V1 and V2. Actually, I can write that better. I know you aren't looking at the tab right now. You're reading the problem. That's what I wanted. So describe V1 and V2 if, and now for part A, they're saying VR with no vectors is equal to V1 plus V2. B, they're saying VR squared is equal to V1 squared plus V2 squared. And C, they're saying V1 plus V2 is equal to V1 minus V2. Okay, so those are the problems they're asking us to solve. I'm going to stop sharing again. Now I'm going to share my iPad, and hopefully it'll work again. It did, yes. So I've got that written down. Now, what they're saying in part A is they're saying that the length of the resultant vector is literally the length of V1 plus the length of V2. So if V1 and V2 had any angle other than 0, then it would be shorter than V1 plus V2. Does that make sense to everybody? So here's part A.
Can you say that again? You broke up.
Yes. So in the first part, part A, they're saying the magnitudes VR is equal to the magnitude of V1 plus the magnitude of V2. So what I'm conjecturing is that if V1 and V2 made any angle with each other, like say that's V1 and that's V2, just that slight angle, you can see that V1 plus V2 would actually give a number that's shorter than the sum of V1 plus V2. In other words, the X component and the Y component are actually making the distance sort of that diagonal. Whereas if they were both the same direction, then V1's length plus V2's length would add to give you the sum of those two. Does that make sense to you guys? So what they're saying for part A is that V1 is parallel to V2. So that writing that I put with two parallel lines between it, that's a typical way we abbreviate something's being parallel. Now, part B, they say VR squared is equal to V1 squared plus V2 squared. I suspect y'all might have an inkling of what VR looks like, what V1 looks like, and what V2 looks like. Anyone?
It's a 90-degree angle.
Yeah, because it's following the Pythagorean theorem. So this has to be something along the lines of V1, V2, and VR. So V1 is perpendicular to V2. Now, in both cases, V1 or V2 could be 0, and then all bets would be off. Like if V1 0 in part A, then yeah, it's VR is equal to V1 plus V2 is always true. Same thing if V2 0. Same thing with this one. If V1 or V2 0, then yeah, of course, VR is going to be the square of VR is going to be the square of the one that's not 0. So just keep that in mind. So we're making the assumption that it's not 0. Now for part C, we're told that V1 plus V2 is equal to V1 minus V2. So when you add V1 and V2, you get the same thing as when you subtract V2 from V1. So is that possible? Well, what I was thinking is if you add V1 and V2, you could, for instance, do like this. And that would be V1. And then you could do V2 like that. And then V1 minus V2 would actually be V1 plus a negative of V2. So it would actually be like they were parallel. And you'd get, since I got 1, 2, 3, 4, 5, 6 blocks on this one and 4 blocks on that one. 6, 1, 2, 3, 4. That would be V1 minus V2. Just this part, not that part down there. But the length would actually be equal to the length of V1 plus V2. Because V1 length was equal to 1, 2, 3, 4, 5, 6. And V2 was equal to 4. So notice V1 plus V2 is 6 plus 4 is 10. And then V1 minus V2, the magnitudes of those, in that case, it'd be 6 minus 4 would be 2. So that doesn't work. So you start thinking, what else? Well, V1 plus V2 is equal to V1 minus V2. What if V1, let's say V1's 5, 1, 2, 3, 4, 5. And let's say V2 is 3. So V1 plus V2 would be 8. And V1 minus V2 would be 5 minus 3 would be 2. That wouldn't work. But the magnitude of V1 minus V2, so that doesn't work either. So cross that out and cross the 8 equals 2. So they cross that out as well. What happens if, say, V2 was just 0? Obviously, V1 plus V2 would be the same thing as V1 minus V2. And V1 equals 0. Then V1 plus V2 would just be equal to V2. And V1 minus V2 magnitude would just equal to V2. So that works. If V2 equals 0, then going in here, then V1 plus V2 is just equal to V1, and V1 minus V2 is just equal to V1 as well. So that works as well. So there's two scenarios in which that works. Can anybody think of another scenario? So really what we're leaning towards is something called the triangle inequality. And the triangle inequality is really neat because if you think about it this way, you can say, let's call this vector A. And let's say we're going to add a vector B to it. Now the length of A and B are fixed, but B could be at any angle. So you imagine B can be in any of these angles right here. If the angle happens to be 0, then A plus B vector has a magnitude equal to A plus B. If it is the angle's 180, then B would be turned around all the way back on itself, and you'd end up getting A minus B. So that's the way you can get A plus B and A minus B. So the only way possible to do that is basically letting, in the left-hand side, you could let B be at angle 0, in other words, parallel to A, and then the right-hand side, you'd have to be B anti-parallel to A. And there's no way both of those could be true. So I think the only scenario that works is V1 and V2 equal to 0. You guys see any discrepancy with that? Y'all see a contradiction or something that I might be missing?
Can you say that thing about the angle again? It has to not be 0.
Okay, yeah. So, and actually, let me do it with a little bit more graphics, if you will. So I can imagine now, since I let the magnitude of B be fixed, you can imagine a circle centered right here, whose radius is the length of B. So that means B could be this, 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 all these different ways B could be added. The longest case, in other words, if you want the biggest magnitude, is when A and B are parallel and you get A plus B. And then the shortest is A anti-parallel to B. And that is R is equal to A minus B. In other words, and you could also say, you see what I'm saying about that now? Fixing the magnitude of A, fixing the magnitude of B, and then you can, because you can call the x-axis any direction you want, so you can certainly put any one of these vectors along an x-axis, which is what I did sort of with A. Now I'm just going to let B spin around, and that's a perfectly general problem. You see that the only thing that can come from it is any one of those vectors that I hinted at inside that circle. So the magnitude can be as small as A minus B, but can't be any bigger than A plus B. So when they're arguing that V1 plus V2 is equal to V1 minus V2, that's two contradictory issues. V1 plus V2 only happens when they're parallel, and V1 minus V2 only happens when they're anti-parallel. If you assume, obviously that would be R is equal to V1 plus V2, which is what they said originally right here. Actually. So the case C can only be true if V1 is equal to 0 or V2 is equal to 0 or both are equal to 0. Any questions on that? Nada? All right, so let's stop sharing for this a second. Let's find another problem for you guys to work, or for me to work for you guys. So I'm going to say, here it is. Did y'all see anything up here that jumped out at you as something you wanted to do in 1 through 18 anyways? I think they all look pretty straightforward. Let's look into vector kinematics. I did today for my class, I did number 19. No, I didn't do number 19. I don't know what I did for my class. This doesn't look like any of the things that I saw earlier today. There's she. Oh, there it is. Yeah, I did 26 for my class today. Let's try. Let's try, I don't know, 27. A particle's position as a function of time is given by R equals 5.0 t plus 6.0 t squared, I hat plus 7.0 minus 3.0 t cubed meters, j hat at time 5.0 seconds. Find the magnitude and direction of particles displacement vector R relative to the point R0. That's kind of a nice problem, but I think I really like 26 a little better. Yeah, even though I worked that for my class earlier today, and I'll be posting a photo of it. One of my students takes photos. I'll put it in on your week's module as well. So I'm going to go ahead and do 20. Thought it was 27. That's weird. Like, I copied that 8:35 earlier. That was wrong. It was 8:15. And then today I worked a problem 26, but I could have sworn it was 2.5, not 3.5. So let's work number 26. But that's okay, because even if we change the numbers a little bit, that's actually just giving you another problem to solve. So 26 says, suppose the position vector, that's that R vector that I showed you last week when I did sort of an arbitrary vector for projectile motion. I said that R vector, R, in this case is going to be equal to 3.0 t squared. And now I'll put parentheses around that and write I hat, and then plus negative 6.0 t cubed. I'll put parentheses around that. Well, first I'm going to make that look a lot better. T cubed. And I'll put a j hat, and then I'm going to put a square bracket around that because that's the next up. and I'm going to stick a meter next to it. Now, R has to have units of meters, so that meter being out there is a good thing, but they're actually not telling you everything. In order for this to really be true, the 3 has to have units. Can anybody tell me what unit the 3 must have?
Meters squared.
A reciprocal meter squared, yes. So 3 would be 3.0 meters to the second to the -2 power. And what do you think 6 would be?
-1.
The -6.0 would actually have to have units of seconds to the -3, because it's got to cancel out that t cubed. But you might have slipped off and looked at a different problem by accident. I do that all the time. Now, I've written the vector down. I haven't shared my iPad screen with you yet, but I want to write down the rest of the information before I do. So it says, suppose the position of an object is given by that. Determine A, its velocity and acceleration as a function of time. So A, I want to know V of t equals question mark, and A of t equals question mark. So that's what I'm wanting to do in part A. And then part B, it wants me to find R and V at a very specific time. So that's R of 3.5 seconds is a question mark. And they're going to say V of 3.5 seconds is equal to a question mark. Okay. So now I can stop sharing this. I've gotten all the stuff written down. And now I'm going to start sharing my other screen. Hopefully this will work again. So far, so good. It's been nice. Okay. Now it's saying unable to connect. Of course it does. Okay, so what I'm going to do, I'm going to turn off my, let's stop this too, just in case. I'm going to turn off my Wi-Fi, my wifey. I'm going to turn that off. Now I've turned it off for a little while. I'm going to now turn it back on. I'm going to open up GoodNotes again, and now I'm going to attempt to share again. Hopefully it'll work this time. Now I'll try to hit here. Yes, it worked. Okay, so got lucky. It worked that time. So first off, what we know in terms of the solution, part A, V, we learned was dr dt. In general, we learned V is equal to dx dt, but of course that was technically only in one dimension. So that would be in 2 dimensions, that are 3 dimensions. That would be Vx equals dx dt, Vy equals dy dt, and Vz equals dz dt. Obviously, you could make the vector R be x times I hat plus y times j hat plus z times k hat. And then you'd see that clearly I'm just going to take the derivative of all those parts. So the derivative of R is going to become, notice the 3.0, which by the way, we said 3.0 had units of s to the -1, and the 6.0 had units of s to the -2 actually on this one, sorry. And this had units of s to the -3. So just keep that in mind. So when I take a derivative of 3.0 t squared with respect to time, I get 6.0 t. Put that in parentheses, put an I hat after it. And then when I take the derivative of -6 t cubed, I get -18 t squared. And actually I can make a plus, put a parenthesis there, put a j there. And now I can do my square bracket and write a meter there. Now you can see that when you take that 18, that still has the same units that 6 did. So it'd be seconds to the -3. But when you multiply that by seconds squared, you only get seconds to the -1, right? Does that make sense? So when you multiply the J component times the M, you're actually going to get meters per second, which is what we expect. Do you see also that the 6.0 T, that's going to have the same units as 3.0 had. So that'll be seconds to the -2 power. But you're going to multiply that by T. So that's going to get rid of one of those. And that's just going to leave seconds to the -1 power. So again, for the I hat component, you get meters per second, which is exactly what we expect. So does everybody follow that? I will put a little note in here. Just to remind us so that the whole thing comes out in meters per second. Now the acceleration, A, is actually dv dt. So now I take the derivative of this, the derivative of 6t is just going to be 6.0 I hat. I don't need a parenthesis with that, but the other one's going to need one, so I'll put it in there anyways. Now the -18t squared, that's going to become -36.0 T J hat, and the square bracket now will be followed by a meter. Again, I will reiterate that this has units of seconds to the -2. This has units of seconds to the -3. And therefore, this whole thing would have meters per second to the -2, which is what we expect, or actually seconds in the bottom would be +2. Any questions on that?
Yeah, just a quick question on how you're doing your math. Why do you keep changing it to a plus and then having a negative value?
Just because I don't like having a negative separating I component, I hat component, and a J hat component, because sometimes you just roll right over that when you're doing derivatives and stuff, and you drop the negative by mistake. So I try to, if it's negative, instead of having I hat minus 36.0, I try to put it plus and then a parenthesis. You don't have to do any of that. It's just something I've learned over the years that keeps me from making boo-boos. Dumb boo-boos, of course, but still boo-boos just the same. Does that make sense to you?
Yeah, thank you.
No problem. Anybody else have any questions? All right, so part B, they wanted to know R of 3.5. Well, R of 3.5 seconds is really supposed to be 3.0. Here I go putting seconds to the -2 in, times 3.5 seconds squared I hat, which I'm going to put in square brackets now. Again, I go parenthesis, square bracket, and then the next one is curly bracket. And then again, I'm going to use my plus here. I'm going to say -6.0 seconds to the -3 times 3.5 seconds cubed. And now I'm going to close that off with a square bracket and say J hat. And then I'm going to close that with a curly bracket and put a meter out here. Now I'm going to do the math. 3.0 times 3.5 squared gives me 36.75. Carrying a couple extra sig figs. And notice that second squared cancel out with the 2 seconds in there. So I get no unit there. I hat. and then -6 times 3.5 raised to the third power. That gives me -257.3. Okay, both of those are bad. Again, no units on that one. Notice I didn't put the plus in there because what the heck? J hats here. But again, no units cancel out because it's meters, seconds to the -3 times seconds to the 3. So I just get plain meters, and that's what the vector is. Now they want magnitude and direction. So I could say R is equal to, and you guys can trust me on this one. Notice it's a X component that's positive and a Y component that's negative. So first off, I'm going to take the Pythagorean theorem and square the first term. And square the second term. But you got to be careful. You got to use parentheses. So I'm going to say in other words, I actually didn't use parentheses and it caught me off guard. And I'm going to say inner. Well, that's not right either. Get back in there. Okay. Now I'm going to take my -257. I'm going to say enter. And now I'm going to say square that. Okay, I got 670 or 67,528. And now I got to take the square root of that. And that gives me 259.9. 259.9 meters is the magnitude. Notice I carried 2 extra sig figs again. Now the direction you can see is going to be a negative angle, and it should be a negative angle way bigger than 45 because it's literally like 260 down and only 36 across. So I'm going to take the inverse tangent. Notice I do not use any negatives inside the inverse tangent. I'm just going to say, crap, my calculator makes it so easy to hit tan instead of inverse tangent and vice versa. So inverse tan. Now what I'm going to do is the opposite is the y. So I'm just going to type in positive 257.3 divided by, notice I did put positive, 36.75. And that's going to give me an angle of negative, it actually gives me an angle of 81.87. But I know that that angle has to be negative because it was had a negative y component, a positive x component. If you need to take time to draw it, then by all means do it. I figured after just working that example, y'all probably didn't know it, but it would look something like this. And what you draw is, let's say, this little guy. Well, oh, that wasn't helpful. Okay, so now I'm going to draw the x component this way, very, very short now. And then the y component is going to be really, really big and negative. Like that. Okay. And then I'll just say that's the vector. Actually, I shouldn't say that. That's the vector R. And this angle right here would be theta. So you can see that angle is going to be negative. So that's all you had to do. You just remember this is, of course, 257.3, and this is 36.8 maybe. You can see that's grossly out of scale, but it's close enough. And then you just take the inverse tangent of that without using any signs. Never, I advise you never to put a sign in a trig function. Okay. It just, you have to know your quadrants and trig stuff pretty well to do that without getting a boo-boo. So I don't recommend you doing it. So now that I got red selected, I'm going to go ahead and circle this answer. So that is the R vector, magnitude, direction. Now let's do the V. So they want V of 3.5 seconds. So in this case, it's going to be 6.0 seconds to the -2 times 3.5 seconds I hat minus, notice I'm dropping the plus now, 18.0 seconds to the -3 times 3.5 seconds, and this time it's squared, and I just have a j hat. So now doing the math, I get 6 times 3.5, which should be 21. And notice that's seconds to the -1 power I hat. Oh yeah, by the way, this thing had a meters after it. And that's seconds to the -1 power there. And now I'm going to do 18 times 3.5 squared. And that gives me -220.5. Again, carrying an extra sig fig. That unit comes out to seconds to the -1. Again, j hat. And that's meters. So now you see that the units for the whole answer is actually meters per second. So I'll put that here, put that here, and you'll see you get meters per second. Now, again, that's just the components, and what they want is magnitude and direction. So I'm going to say V is equal to, and I'm going to draw my little coordinate system over there on the right again. I mean, on the left again. Notice it's still a positive X component and a big negative Y component. So I'm going to draw X like this. And I'm going to draw Y like that. The X component is going to be positive. So it's very small. Of course, it's very bad there too. Okay. Now I'm going to draw an itty bitty X component. Okay. Now I'm going to draw a really big Y component, but negative. Okay. So now what and that's supposed to be perfectly vertical. So ignore what part that says it isn't. So that's going to be my V vector right there. And of course, this angle is going to be theta. So I'll take the sum of the squares. I'll say 21 squared plus parentheses -220.5 squared. That gives me 49,061. Now I'm going to take the square root of that. And that gives me 221.5. .5, and that's meters per second at. Now I'm going to take the inverse tangent of 220.5 over 21. So that gives me trig tangent inverse of 0.5 divided by 21. And that gives me 84.56 degrees. So I'm going to say this is negative 85 degrees. And that's our answer. Any questions on that? So now I want to go ahead and do a quick, we only got like 10 minutes left. I want to do a decent projectile motion problem. So I'm going to stop sharing that and I'm going to start sharing the book again. And projectile motion problem, I think might be worthwhile. Is this number 42? Let me see, 3.3-45. Which one's asking for 3-45? Yeah, 42. Okay. So we're going to do number 42 now. So number 42 says a projectile is shot from the edge of a cliff 125 meters above the ground. So I'm going to draw a little cliff. Okay. I'm going to say that height of that cliff is h equals 125 meters down to here. And it's shot with an initial speed of 62.0 meters per second. So I'm going to draw yet another vector. And that one's going to be V0 equals 62.0 meters per second. But it's also going to have an angle theta equals 35.0 degrees, like that. Now the actual projectile is going to do something quite different. It's going to follow this arc, which you all see in a second. Okay. Okay. And what they want to know is what is X, that distance that they show right along the ground. So I'm going to go back here and say this right here is X equals question mark. And that's that. Okay, so now I've gotten down all the information. It says, as shown in figure 345, determine the time taken by the projectile to hit point P at ground level. So this is the point P. So T equals question mark there. B, determine the distance X of point P from the base. So that's part A. Part B was X equals question mark. And find C, the horizontal and vertical components of velocity. I'm still writing stuff on the page. Hold on, guys. I'll get there in a second. And then what, part D? Anything else? Oh yeah, it's got a buttload of stuff. Magnitude of velocity. And E, the angle. and F, the max height above the ground. So F, I might not be able to get to that one. I'm going to say H max. All right, so let's kill this share. I've got 5 minutes left. I might be able to do this. We'll see. Hopefully I can share the screen again. Pull this up, pull that down, hit that. Nope, it's not going to let me again. That's so convenient. I really like when this happens. Turn off the Wi-Fi. Stop the share. Turn on the Wi-Fi. Start the share. Okay, so that's the picture I've got drawn. So first thing we want to know is X. So really what I need to do is I treat projectile motion as if the horizontal and vertical motions are entirely separate. And that's what I'm doing here. I am actually going to treat this down here as the coordinate system. So there's my x-axis, there's my y-axis, and my origins right there at the base of the cliff, just for completeness. So now I'm going to say solution. So part A, they want to know what is X. Well, X is basically the distance traveled horizontally, which is gotten by the fact that the X is equal to just the horizontal velocity times time. Well, you can see that V0X is actually 62.0 meters per second times the cosine of 35 degrees. And that gives you uh, 50.79 meters per second. And then V0Y, of course, is just 62.0 times the sine of 35 degrees. I'm going to assume you know how to do that and ignore and not show you the full work on that. I've already stated what it was, but it should be 35.56 meters per second. And I've carried one extra sig fig there. So that V0Y is just 62.0 times the sine of 35, in case anybody's wondering. So what we're imagining is I throw a ball straight up at 35.56 meters per second, and I'm going to allow it to reach a max height, and then I'm going to allow it to fall down an additional 125 meters. So I can use that max height to figure out part F. All I have to do is say, I'm going to set the final vertical velocity equal to 0 and use V equals V0 plus AT, where A is negative 9.8, and that'll give me the time to basically the H max. And then if I want the H max, I just got to figure out how high it is by using, say, V squared equals V0 squared plus 2A X minus X0. So that's just a rough outline of how to do F. But part A is straightforward now. I need to compute how long it's going to be in the air. So I want the equation for Y is actually Y equals negative 1/2 GT squared plus V0Y T. In other words, I already calculated V0Y. That's why I didn't put that. And then its initial height is 125. So I would say plus H. So what I want to know is T when Y equals 0. So I'm going to say 0 equals negative 4.90 meters per second times T squared plus 35.56 meters per second times T plus 125 meters. So that's basically a quadratic equation. The solution for a quadratic equation, x is equal to negative b plus or minus square root b squared minus 4ac over 2a. So I'm going to say t is equal to negative b. So that's going to be negative 35.56 meters per second plus or minus the square root of 35.56 meters per second squared. Again, remembering that 6 is an extra digit, minus 4 times negative 4.90 meters, which I'll just write as meters per second squared, times c, which is 125 meters. Notice that's meters squared per second squared, just like the other one. So all that, once you take the square root, it's just going to have units of meters per second. And then 2 times a would be negative 9.80 meters per second squared again. So I'm going to take 35.56 and divide it by 9.8. That's a negative divided by a negative. And that gives me 3.628. Or excuse me, 3.629. And that is meters per second divided by meters per second squared. So that's just seconds, plus or minus. Now I'm going to take 35.56. I'm going to square that. I'm going to add to it 4 times, because the negative and the negative cancels out, 4 times 4.90 times 125. That gives me the square root of 246,265 meters squared per second squared over negative 9.80 meters per second squared. So that's going to be 3.629 seconds plus or minus. Take the square root of that number, divide it by negative 9.8, and I get negative 50.63. Whoa. So I get negative 50.63. Actually 64 seconds. I don't know that that number is trustworthy, but you can clearly see that 3.629 minus 50 is not a reasonable number. So I'm going to have to do 50.64 plus 3.629. So I'm going to say t is equal to 50.64 plus 3.629. And that gives me 54.26 seconds. So that's how long it's in the air. That means x is supposed to be equal to 50.79 meters per second times 54.26 seconds.
Hey, Professor,
Yes.
I just wanted to let you know that lab starts in about 25
Yeah.
minutes. So
I'm going to finish this out for you guys. Y'all are free to go. It's well past, it's 3 minutes past your class time. So y'all are free to go. I'm going to finish working this problem. Y'all can check out the recording later. If anybody's got time to stay, you're welcome to, but I wouldn't recommend missing lab. So thanks, guys. So this turns out to be 2,756 meters is how far it travels. That's extra sig figs. Again, I'm really suspicious of this 50.60 seconds, but right now that looks like what the answer is supposed to be. So I'm going to box this off. I'm going to continue solving the problem. Again, my students have left now, but I'm going to continue solving the problem so they'll at least I'll have the record of it. So there's part A. Part B, they want to know Vx and Vy at the end. Well, basically what you're going to do is use that same time again, which I don't really like using because I still feel like that 50.64 was really huge, but I don't see any reason for it not. Let me check my math. 35.56 squared plus 4 times 4.90 times, yeah, I guess it's got to be big. All right. Oh, that's a lot smaller than it was before. That makes me feel better. Now I'm going to take the square root of that. Now I'm getting the square root of 3,714. So I'm going to write in here that there is clearly an error. This time I got 3,714. I'm going to check it again. 35.56. Well,
I got the same thing, Professor.
you did. Thank you. Okay. So that when I actually correct for that, instead of 50.64, I get 60.9. Whoa, that's just as big. Oh, yeah, that's just as big. But before I divide it by 9.8. So divided by 9.8 gives me 6.21. That makes much more sense. So this is 6.219 seconds is what that's really supposed to be. So I'm going to go ahead and erase this part. Thanks for checking me on that. Okay. I don't know how I made an error. I got a big screen calculator, but my glasses don't see that well when it's that far away. So my time in this case, I could be 3.629 minus 6 seconds. That give me negative time, so that's not useful. So I'm really going to take the sum of those two, 3.6219 plus 3.629. That gives me a time equal to 9.848. Carrying extra sig figs. So I'm going to say 9.848 seconds times that velocity. Now that gives me X is equal to 50.79 times the 9.848. And that gives me 500.2 meters. So that answer does feel a lot better to me. So I think that's probably right. Now I've got an answer for T. So really all I have to do for part B, Vx is going to not change. So part B, whoa. Vx is equal to V0x is just 50.79 meters per second. Again, oh, they actually did give me 3 sig figs, not 2. So I've been carrying
I think your name is said part C, because part B is X and part C is V of X.
I missed what you said. What did you say there?
I think this is part C, the V of X. Part B was the 500 meters. Part C.
Oh, gotcha.
Is
Oh,
the
part
V-
A was just the time.
the time.
Yeah. Okay. So thank you for that. Yeah, I completely missed that too, didn't I? So actually, I was doing it right in terms of the A. So I'm going to say this part is A. I'm going to circle that. This part is B. I'm going to circle that. This part I'm going to erase and pretend like I didn't do it wrong. And I'm going to put C right there. Now the V0Y, or excuse me, VY is going to be V0Y plus AT from our kinematic equations. So that's going to be, that's some terrible writing there. VY is equal to This was 35.56 meters per second upward, plus, or well, I'll say plus negative 9.80 meters per second times time, which was 9.848. I'll write like this. Seconds. And that will give me negative 60.95 meters per second is how fast it's going in the y direction. So they actually specifically asked for Vx, Vy. So in this case, I'm going to say V is equal to 50.8 meters per second I hat minus 61.0 meters per second J hat. And that'd be part C. Actually, I like color, boxing it with a different color. And then if you actually want to know the magnitude and direction, again, we can draw our same little coordinate system doohickey. So I'm going to say it's obviously in the fourth quadrant. So I'll draw a horizontal this way and I'll draw a vertical this way. I will put over here, this is part D. And what I'm going to draw is a blue. Actually, I'll draw a green positive component, which is 50. And then I'll draw a blue negative component, which is slightly bigger. So again, we should get greater than negative or more negative than negative 45. So this should be 61.0 and this should be 50.8. And I'm going to say this right here is V and this is phi. So V is actually going to equal 50.79 squared plus 60.95 squared. Take the square root of that. And I get 79.33. 0.34 actually meters per second. And now I'm going to say at, and phi is going to be tangent inverse of 61 point, or actually I'll use the extra sig fig, 60.95 over 50.79. And I'm going to say trig function tangent inverse 60.95 divided by 50.79. That's going to give me 50.20. Carrying an extra sig fig. So I'm going to say this is at negative 50.20 degrees. And that's part D. And then part E, actually that's part D and part E. So I'll say D and E's right there. And then finally, they wanted to know, oh, H max. So we can use part F. Let me see, part F. Part F, H max is question mark. But what I know is T at H max implies Vy is equal to 0. So I'm going to use Vy equals V0y plus AT. And that's going to give me 0 is equal to V0y was 35.56. minus 9.80 meters per second times t. So that gives me t is equal to 35.56 divided by 9.80. And that gives me 3.629. Seconds, which y'all might recognize from your previous part. So that's the time. Now all I gotta say is, what is y? Well, y at 3.629 seconds is just equal to negative 4.90 meters per second times 3.629 seconds squared plus 35.56 meters per second times 3.629 seconds plus 125 meters. So when I do that, I'm going to get when I did all that calculation, I got 189.5. Meters, and that's the total height to the ground, from the ground. And that should do it. Okay, barring any extra careless mathematical mistakes. That's it. It looks like only one student's left here, and that's cool. As I told you, the time was up. So class is over. Thanks for coming, everybody. I'll wait for the last person to leave. Other than that, I will see you next time, and thanks for coming. James, did you have a question, sir?
Yes, sir. I just wanted to talk about the textbook and the access code.